Good day and welcome. We do the reduction formula. We look at video 6. Here we will have a slightly different approach as to where we would normally be. Our example that we work with is they ask us if sine of 17 degrees is equal to A, without the use of a calculator, express the following in terms of A. So the first thing that we need to do is to set up this that it shows as a ratio. What is A? A is A over 1. Then I can say A sine is a Y value over R value. Once I have that, I may rewrite A as a ratio. Press pause and try to write A as a ratio. So writing A as a ratio means it will be A over 1. Right? Now that I know that sine of 17 degrees is A over 1, A value is my Y, 1 is my R, so I will calculate my X value. How do I calculate my X value? Pythagoras says R squared minus Y squared is equal to X squared. So the square X is equal to the square root of R squared minus Y squared. And don't forget, don't put the R value in the place of the Y and the Y value in place of the R. The R value for us is 1. So 1 squared. The Y value is A minus A squared. Calculate. 1 squared is 1 and A squared remains A squared. Now that I have my X value, do remember, 17 degrees is in the first quadrant. So it does not matter what you do, you draw your sketch as the first quadrant with 17. Now it is likewise important to list the other angle also, just in case they ask you a question with regard to the complementary angle, which will be 73. So we put in our values, and does not matter what they ask me, I will be able to comfortably answer these questions. So the first question that is asked is, what is tan of 17 degrees? Now I go to 17 degrees, tan is the opposite side over the adjacent side. So my answer is A over 1 minus A squared in a square root. That's it. I don't have to battle with anything else. That is the next question that is asked is sine of 107 degrees. So working with 107 degrees, I can easily say that that is 90 degrees plus 17 degrees. So I rewrite it as sine of 90 degrees plus 17 degrees. Next step, I need to activate the co-ratio, and the co-ratio of sine is cos of 17. 90 degrees plus, that will be in the second quadrant. Sine is positive in the second quadrant. Hence my answer will be positive cos of 17 degrees. There's 17 degrees. Cos is the adjacent side over the hypotenuse. So it's the square root of 1 minus A squared over 1. So that will render me the square root of 1 minus A squared. Now, if you decided not to have taken the 90 plus 17 and you said 180 degrees minus 73 degrees, how will this have panned out? So this through reduction would have been sine of 73 degrees. If I'm standing at 73 degrees, sine is the opposite side over the hypotenuse. My answer is exactly the same as I did when I went the 90-degree route. Our next question says calculate cos square of 253 degrees plus sine square of 557 degrees. Before we go any further, I would like to explain something with regard to reduction. When I work with an angle, I will write that angle in terms of an acute angle, or I will write that angle as 90 degrees plus or 90 degrees minus, or I will write the angle as 180 degrees minus or 180 degrees plus. I will write the angle as 270 degrees minus or 270 degrees plus. I will also endeavor to write the angle as 360 degrees minus. When an angle is greater than 360 degrees, it is important that I try to subtract 360 degrees from that angle until the angle is smaller than 360 degrees. For example, the angle is 750 degrees, then I know 360 plus another 360 will give me 720. Then I will add another 50. So I will say 720 plus 30 to give me 750. If the angle is 455 degrees, I will say 455 minus 360 degrees, and I will get an angle of 95 degrees. That means the second quadrant. But I also need to understand that when I write this angles that is greater than 360 degrees, I need to make sure that I subtract 360 until that angle is smaller than 360 degrees. So let's apply what we've learned. So I have 253 degrees, so that's less than 360. So I can write it as either 270 degrees minus, or I can write it as 180 degrees plus. Ideally, I can see if I add 17 to that, I'll get 270. So that will give me sine of 17. But I can do it also as 180 degrees plus 73 gives me 253. I can decide here for 557, it's bigger than 360 degrees. So I go around again, so it is 720 minus 163. Now a person would most probably have just said, right, if I go 1.5 times around, it will be 540. Then I only have to add 17 to that. But it is not as easy. You must work with full cycles of 360, and the moment the angle will be less than 360, you can apply the other rules of reduction comfortably. Right, so let's follow the rules. First step, I decide 270 minus because that takes me to sine 17, which I already calculated. So 360 plus 197 degrees. Now I will work with sine square of 197 degrees. On this side, it's still cos of 270 minus 17. Cos in the third quadrant is negative. So I'll work with negative sine 17 all squared. This whole thing will be squared. I know I'm going to get a positive answer. Right? So whatever happens then here, 197 is 180 degrees plus 17 degrees. Notice we did not say 450 plus 17. because we must work with full cycles. Only full revolutions are allowed when I use reductions for angles greater than 360 degrees. Right. Now we say 180 degrees plus 17 degrees. So this is reduced to third quadrant, negative sine square of 17. So this being all squared, sine 17 is the opposite over the hypotenuse, which is a squared, and a squared is a squared. So my answer is 2a squared. I'll briefly show you another solution to this one. So if I go to full revolutions, it's 720 degrees minus 63. For 253, I said we could have also used 180 plus 73. So that is negative cos of 73 degrees. And this one is sine square of negative 160 degrees. So that will be negative 180 plus 17. This one remains cos of 73. So cos of 73, if I look at my sketch, 73 if I look at cos of 73, the adjacent side of the hypotenuse, so it's still a over 1, but it is negative cos, so the sign is negative there, but all of it is squared, so this will become positive a squared, and sine of negative 17 is negative a. If I square that, my answer is 2a squared. The last question that they asked in this set is, what is sine of 34? Now sine of 34 can be written as double angle identity 17 plus 17. So it's sine 17 cos 17 plus cos 17 sine 17. So sine of 17 degrees would be a, cos of 17 degrees square root of 1 minus a squared. Already calculated that, so I don't have to calculate it again. Then cos will be 1 minus a squared, and sine of a will be a. The reason I'm not writing at the back, because people could interpret it as part of underneath the square root. So 1a plus another 1a, or one apple plus another apple, is 2 of those apples. And there's my answer. I could have also decided to do sine of 2 times 17. So that is a double angle also. So I could write it as 2 sine 17 cos 17, which will give me exactly the same answer. From us, mathematics for the 4th industrial revolution and trigonometry, we want to thank you for watching this video. We will see you in the next video. If you liked it, tell your friends. If you did not like it but loved it, please share your experience with us.